So to talk about direct and indirect lighting in Eevee, I've set up a very simple scene here to test a few things, and I've set it up in a particular way, not only to show how to get the most out of lighting, but also to show you some of the limitations and to understand what we're working with here. So to start, if I set this to rendered, nothing going on here, and we're just going to start with adding in an area light. And this isn't really a chapter on how to light stuff or all the particular light types. It's more on the technical side of lighting things in Eevee and what you need to understand when you're working with some of this stuff. So first thing I'm going to do is I'm just going to add in an area light here. As we can see, let's add in a little bit more. There we go. Suzanne is being lit up, and really, what I want to talk about is direct versus indirect lighting. So area lights or spotlights or sunlights or point lights, they're going to give us both direct and indirect lighting. Now, by default, we're only going to see the direct lighting because as is the case with Eevee, what we need to do if you want indirect lighting, we're actually going to have to bake it. Now, you can't just hit bake indirect lighting because nothing's really going to happen. We'll get to that in just a minute. What I'm going to do first is just talk a little bit about the direct lighting itself and one or two options that we can look at that are interesting, and then we'll move on to the direct lighting. The indirect lighting rather. So in this case, one of the things I want to talk about is the custom distance option. And by default as well, before we move into that, we have in shadows, we have soft shadows turned on, and I've turned up my cube size just a little bit just to get the shadows a little bit nicer. But one of the things I want to talk about here is the custom distance. So in Eevee, we've got the control of being able to set a custom distance for our lights. And what this might be useful for is, for example, when I was making the promotional videos for this course, I'm sort of doing that as I'm recording things. I have text in front of a background that I want to light up, and custom distance is really great for this kind of thing. And I'm just trying to illustrate what this does. The manipulator will show you as well. Basically, you could tell Eevee that a light can only emit so far. So for example, if we just want to light up Suzanne here, we could use a spotlight for the same example as well, but I just want to show you with an area light to see what I mean. We could actually set this distance up to where we only light certain parts of our scene, and we could use it with point lights as well, which is really great because this gives you a lot of control, because lighting in Eevee isn't as simple as lighting in Cycles where you add a light and everything gets calculated for you and it all looks great. And we have to do a little bit more work to get it to look all right at times. So for now, I'm going to turn that off because I just want to use it normally, but it's good to know that's in there. And another thing I want to very quickly talk about is contact shadows. So if we look at Suzanne's eyes here, we can see the shadowing sort of looks okay, but doesn't look 100% right. And this is the reason I've set this scene up the way I have, is if we turn on contact shadows, you can see we just get a slightly more realistic looking result, I guess is what you could call it. Now, if I zoom back out and I turn these off and on again, you'll see that they're very situational. And that's sort of the reason they're turned off by default, is unless you really need them, because they're a screen space effect as well, you're usually not gonna turn them on. So in a scene where I've got a lot of reflections and a lot of stuff going on, turning them on doesn't always help, but it's good to know that if you're lighting one particular object, it can help turning on contact shadows just to get a little bit more detail in your shadows and make them look a little bit better. And we can leave them on for now, but just know in general, if you have a lot of lights in the scene, it might slow things down a little bit. So yeah, so let's actually talk about the second part of this, and that's indirect lighting. Now, as you might have noticed already, this scene is set up with just white materials. They're matte white materials. They don't reflect or anything, so we can just see the lighting by itself. Now, to set up indirect lighting correctly in Eevee, what we need to do is we need to add a light probe to the scene. And by default, this is sort of the size that we get. And just to illustrate it, what I'm going to do is, without changing anything, I'm going to bake the indirect lighting. And hopefully we'll be able to see some of the limitations, but we but not really. We see some weird lines going in here. And as I delete the lighting cache, you'll see indirect lighting is being added to the scene. Now, as you might have guessed at this point, the size of this thing, the size of this object will actually control where the lighting is. So in our case, actually, I'm going to bring it up a little bit. There we go. Bring it up like this. And let's rebake that indirect lighting. Now we're getting a result that's starting to look a little bit better, but it's still not perfect because there's some weirdness going on, like the bottom of our object here, of our plane, or our studio rather, is getting a lighting, which doesn't really make sense. And I just want to talk about how this cache works and how to set it up properly. So I'm going to delete the lighting cache again for now. Now, basically, what this irradiance volume is going to do is it's going to calculate the lighting within these bounds, within the inner set of bounds, and it's going to use a bunch of probes to calculate that lighting, and we'll look at those in just a second. And then it's going to sort of use this as a fall off to where it needs to calculate the edge of it. And now this scene is a very particular case, especially for lighting, and that's sort of why I chose it, so we can see the limitations of this sometimes a little bit as well, and we understand how to tweak it. So I'm going to just scale this out in the z-axis so we reach about the edges of our studio here. And actually, let's bring this down a little bit to illustrate another point. So now these bottom dots are under the studio, and let's bake that again. And we're going to be doing this baking quite a bit, on and off each time. And now we actually do get a correct result because it understands, well, correct, I wouldn't call it correct, but it understands, and we can turn on the irradiance size here, and that will show us sort of all those lighting probes and the lighting information that they've caught from the scene. Now we can see the ones down here are black, so it knows that the bottom is black, and the ones up here are white. But if you look closely, it's actually trying to kind of interpolate between these dark ones at the bottom and these light ones at the top, which means we're still going to get issues because the bottom of Suzanne is dark here as well, and that's not really what we want. So ideally, we need to bring these up. And as you can see, the lighting probes don't move because we need to rebake this before they actually have effect. So let's rebake this. And now we get sort of the correct lighting at the bottom here and outside here, but we still get this same problem that we had before. So to really get this to work properly, we're going to have to move up this edge, make sure that it's sort of above the plane. And maybe let's mess with the fall off distance here a little bit. Make it a little bit tighter, and let's rebake the indirect lighting and see how that looks. There we go. So we're not quite there yet. There's still some lighting bleeding through, so we might just need to bring this up a little bit. Bake the indirect lighting again. And now the light bleed is gone, but we get some light bleed here. So this is why I chose this, this particular example, is now you can see there's light bleeding going on. We can actually see that fall off edge quite clearly from where it starts about here to where it ends about there. So this is very important to think about. So in this case, I might scale this in a little bit. Rebake the lighting. And now only here we're getting some issues, but in general, this looks pretty decent. If I delete the lighting cache, you'll see this actually looks quite nice. If I rebake the indirect lighting, it's looking pretty good. We're still getting that edge here, which is going to be quite hard to avoid unless we set the fall off a little bit higher again. And again, this is all to get everything to look great from camera view. Don't expect to bake indirect lighting for every single scene and that it looks perfect everywhere. Like I said, we're going to have lighting here at the bottom, but it's not an issue because mainly we just want this to look good. Let's say our camera view is going to be here. Then we just want this to look good, and that's the more important part. So we've kind of got this set up. Now we can talk a little bit about how to get more detail in this lighting cache, but I'm going to add some other stuff to the scene before we talk about that. And let's talk about the second sort of lights. And I'm going to turn off the irradiance size for now. And if we talk about indirect lighting, we need to talk about mesh lighting as well. So I'm just going to add in an icosphere and put that over here, maybe. More over here. There we go. And I'm going to add a material to it. And instead of a principled BSDF, I'm going to add an emission. And let's give it a color. Let's try maybe blue or something. And let's set this to 50, so it really emits. Now, at first glance, it might look like it's emitting light, but that's really just a bloom fooling us. So once we turn the bloom off, you can see this should be emitting light, but it's not. Again, this is because it's not a direct light source, it's an indirect light source. So if we rebake our indirect lighting, we're actually going to get that lighting over here. Now again, we can see the limitations of our irradiance volume. So what we might want to do is scale this up on the z-axis. And I try to keep this grid somewhat uniform. So if we rebake the indirect lighting now, we'll get lighting towards the edge. We can see it kind of is problematic here, so we might even scale this up on the y-axis a little bit. And then make sure to move it forward so the edge of our internal bake is definitely in the curve here, so we don't get any clipping issues. Let's rebake the indirect lighting. And again, this is where the limitation sort of happens. We've got this curve, and we can see this is where the lighting ends. You can sort of see it coincides with the outer edge. So this is where we might get some issues. Again, let's change the distance up so that it encompasses our entire studio. Bake the indirect lighting. And now I've got something that looks a little bit better. Now you can see there's some smoothing going on. We can try and smooth this out with the irradiance smoothing setting. It has more effect on curved surfaces than it does on flat surfaces. So one of the things we might need to do is increase the number of probes. So let's take this grid up and let's take it up to a slightly more ludicrous number. And I'm doing this on purpose just to show you the effect of what happens. So if we bake the indirect lighting now, not only is it going to take quite a bit longer, but you'll see the effect isn't necessarily that much better. It is doing some filtering and some smoothing and whatever, and you see that's quite a bit longer to bake. But yeah, again, we could try and mess with the smoothing, but on a flat surface like this, we're never really going to get perfect results. And the reason for that is we're using like worst case scenario. We're just using white materials, and really what we'd want to do is maybe use materials that are a bit more complex, and then this lighting will look a lot better. But I just wanted to show you this, that it's not just a case of adding more dots in and making it look better. In fact, if we bring this down, chances are, while the lighting is not as precise, it looks slightly better. It's still not perfect, but again, it's just down to the limitations of the way the system works. And it's good to know, because we increased the fall off again earlier, that we're getting lighting at the bottom here, but for our case, this looks pretty good. So we are able to get lighting from meshes, but we need to really tweak our irradiance volume to make it look good. So in this case, let's try 5. Maybe that is like a good middle ground. And again, we're getting those lines. So I think the default of 4 might be pretty decent. And you could mess with the bias and really try to get it working. So if we set the blur up, maybe that will help. There we go. It's blurred out a little bit more, but generally, now we're really getting into the nitty gritty of it. And I would advise you to just read up on the individual settings. And the blur didn't really help that much to begin with. So again, what's happening is if we look at our radiance caching here, there's a lot of darkness here, there's a lot of brightness here because there's this one really bright object, and it's trying to sort of get in between these and interpolate in between these. So it's just good to know what the technology behind it is doing. And with a bit of tweaking, you would probably get this right, but I don't want to spend too much time on this. I just want to show you how it works. And let's talk about the final sort of set of indirect lighting. And as you can see, before I move on, if I were to move this icosphere, the lighting itself won't, the indirect lighting itself won't change. So that is a bit of an issue. We'll have to rebake it. So it is static. So if you move any of your lighting objects, you'll have to rebake it, and it does stay static. If we move Suzanne, you can see she does react to it, but we can get these artifacts and things from where she was. So generally, if you're going to start moving stuff around, you might want to rebake your indirect lighting. And for animated objects, unless they're not really touching surfaces, like in Suzanne's case, like if we had a scene where stuff's flying through, you could have the indirect lighting baked and it could look pretty decent. But in this case, because we're dealing with like contact shadows and other things and contact lighting and that kind of thing, it's important to know its limitations and to see how it works. But it does work. So yeah, it's pretty cool. And again, on a more complex scene, this sort of interpolation won't be quite as visible. So in our case, let's see, I'm going to turn off the icosphere, and I want to talk about the last example, and that's actually there we go, let's delete the lighting cache. That's kind of a fun example in the environment shader, and I'll actually show you this a little bit more in detail. If we go into world, I've just plugged in a wave texture and color ramped it down and made it quite large, just so we have one big ball of light coming from the side. Now, if we bake the indirect lighting, you'll immediately see that if you want to use any sort of HDRI or environment lighting, and like I said, this is a wave texture, but this could be an environment texture like an HDRI that you've downloaded from somewhere just as well, and it will work just fine. But to actually get the correct shadowing and lighting from this, you need to bake the indirect lighting. So as I bake this, you'll see it becomes a little bit better. Now again, if we go to the bottom, we'll see the limitations of our bake, and let's just bring up the amount of points in our radiance volume. So let's maybe set this to 6, a little bit more finer lighting. There we go. It takes slightly longer, but it just looks a little bit better. Again, because we're dealing with one light source, this is worst case scenario, and it's not really showcasing what it can do. It's just to show you that you need to think about how your lighting is set up, and you might need to tweak things a little bit if you want it to look correct. Now, if we look at the irradiance size, you can see exactly what's happening. If we turn this back on, it's grabbing that light, and I mean, we could even change the color if we wanted to. So let's change this to red, bake the indirect lighting. Now I've got a red size, and if I delete the lighting cache again, you'll see there's no shadows, and especially when it comes to HDRIs, there's a lot of screen space stuff going on as well that you might want to think about and consider when you're working on things. So if we rebake this, it takes a second to bake. We actually get the correct lighting and the correct bounce lighting as well. Now we could go crazy with the diffuse bounces if we wanted to, and I'm not going to set it to 100, but 10. But again, this will slow things down significantly, and it doesn't really always add that much to it. I think the default of 3 is fine, unless you're in a very specific case where you've got a lot of low lighting and you want the light to bounce a lot. You might crank this up, but in general, the defaults work quite well. So there you go. A little bit less bright. So if we try to compare here, there's some darkness here. Yeah, it might be a tad bit brighter, but it doesn't really make that much of a difference. Still baking, so give it a second. A little bit better, but again, I chose these scene setups to be very worst case scenario. Like, you're very rarely going to do this. And let's grab Suzanne, for example, and set her to object. And the moment we change this to maybe a reflective shader, all right, grab our principled, and we set the roughness down. You can see it's grabbing a little bit more. And if we bake the indirect lighting, just with the added reflections in here, we get a lot better result. And the sort of the oddness of the indirect lighting gets hidden a little bit with the reflections. So let's go back in and actually turn everything on now and rebake our indirect lighting. And now you can see we get lighting. We get red lighting from the side from our HDRI. We get blue lighting from our mesh light. Let me turn off the irradiance probes here, and we get lighting from the top. And again, this light is extremely bright, so what I might do is just bring this down a little bit, rebake it. It's not going to be quite as extreme, but once more, because we're just dealing with a flat white surface, you can sort of see the indirect lighting in here. So it's just something to take into account. You know, I've said it a few times now. If you've got a more complex scene, it's going to look quite a bit better, and you don't have to worry about it. You can mess with the smoothing, but it's not really going to do that much. Like I said, it's mainly going to be visible on some of these more curved surfaces. So with that said, that's an overview. Again, if we were just to set this scene up by default, this is what it's going to look like. If I were to change this to maybe a different color, maybe this is green, we bake the indirect lighting. Now we're going to get green bounce lighting over here on Suzanne from the white light in the top here bouncing on the green studio and bouncing back. We're going to get blue bounce lighting from our light in the icosphere, sorry, and we're going to get red bounce lighting and in this case reflections from all three as well from our world shader. So there you go. And even if you just look at this, sure, ignore this for now. Again, like I said, I've talked about what that is. But if you just look at the difference between this and as we bake it, this looks a lot better. It looks a lot nicer. It looks a lot more realistic. So that's really how to get the most out of lighting in Eevee. So it's good to know that you can use mesh lights, but you know, especially if they're over bright, you might need to tweak them a little bit and need to think about how your radiance volume is set up and where the limits are and things like that. So let's rebake this with a slightly lesser. There we go. The mesh light is a little bit less. We're still getting some of that weird bleeding, but it is what it is. Bring down the irradiance volume, bring down the amount just to tweak it. Let's see. We don't need the blur. I think the visibility, actually I was wrong earlier. So we turn this back on. This blur actually pertains to the dots, I believe. And we'll have to rebake it, I think. Yeah, it just pertains to how these are being shown. I believe I was wrong there. There we go. With just a little bit less, we get slightly less visible seams in the lighting. Now this actually looks quite usable. So again, it's just a case of going in and tweaking. And for real time, this actually looks very nice. Remember, if I move Suzanne around, you know, she will be affected by the map that's been baked, but sort of the limits here of where she was might actually pose a problem. So there we go. Yeah, I think that was quite an extensive, one of the longer videos as well. But now you know how to control this stuff and why the radiance volume and the indirect lighting is so important. Now, I didn't talk about the cube map size and things because we're going to talk about that in the next video, which is going to be about reflections. But for now you know how to control indirect lighting in Eevee. And yeah, I would definitely advise practicing this a lot, and you will get the hang of it. It's just a case of tweaking settings and getting used to the system and how it works. So yeah, with that said, I'm sure you've guessed it, but it's time to move on to the next section. Now that we've looked at indirect lighting, it's time to talk about reflections. And reflections in Eevee, due to its real-time nature, are quite interesting. And we need to do some optimizations as well to get the most out of them. And to do so, I've set up a scene that shows all the different situations where we need to optimize and sort of allows us to talk about the nature of reflections in Eevee itself. So to begin with, one of the things I've done is turn off bloom. If I turn this back on, you'll see I've got some reflective objects in here, just some stuff to reflect in Suzanne. And the Suzanne herself has a metal shader. The back here is just a metal shader with 0 roughness, so it's a complete mirror. And the torus over here actually has a glass shader on it. So when we talk about reflections and refractions, we need to figure out how to optimize these and get the most out of Eevee. And I'm going to turn off bloom for this example because I just want to focus on everything that's reflecting so we can actually see what's going on. Now, one of the things you might notice is as I move the camera around, the reflections on Suzanne sort of disappear because the blue sphere over here actually moves out of the camera view. And the same can be said over the red sphere over here. And that's because it's in the name itself. These reflections are what's called screen space reflections. So that means they're only going to reflect stuff that is visible in your screen. So if we go back to our camera view, because the red icosphere over on the other side isn't actually visible, we're not going to be able to see it in our reflections. So we need to fix that and figure out what's going on and how to optimize this and make it correct. Now, first thing I'm going to do is actually crank up the general, I guess, quality of the reflections. And by default, reflections are being traced at half resolution, and I tend to turn this off. You can immediately see they become, and again, if I zoom in, this disappears. So hopefully it's visible enough in the recording. If I turn these on, you can see they're a bit more blocky, and generally I'll turn the trace precision up as well, just so we get really nice defined reflections. Like if we go back to what it was, you can see there's less reflections here. We turn on half res trace. The difference really is quite big. Now we're getting a lot more definition in our reflections, which is quite nice. Now, I'm going to not talk about the thickness and edge fading too much. Really, they're just to control how much extra reflectivity you add in and how much of it you can sort of fade away. Again, reflections are more of a tool than perfect reflections in Eevee. I want to talk more about how to get the most out of them. So in this case, we've got a torus which is glass as well. And if we want to make sure that this glass torus will be able to refract stuff, we're going to have to turn on refraction. Now, by default, you can see I've just turned off the overlays. I've still got the torus selected, but it's not refracting. So what's up with that? So we can either do this over here in the settings, and you can do this in the node view as well, but I'm just going to show you over here. To enable refractions in Eevee, what we need to do is first turn them on at a render level, and then for each different material that we have, we need to turn it on separately. So now when I turn it on, you'll see these screen space refractions will actually start working. Turn this back off, and it just looks like a metal shader because it doesn't know what to do. Turn these on, and there we go. Now we can tweak the depth and all that kind of thing. But again, this is stuff that you might want to tweak depending on your scene. For now, I'm going to leave most of these set to default because we get a fairly decent result. It's more about the reflections as well that we need to think about. How do we get this stuff in? So I want this red object over here to reflect in my final render, because obviously it's there and I want it to affect everything. So the way we need to do this is similar to where we had an irradiance volume for lighting. We've got two types of light probes for reflections, and we're going to focus on the reflection cube map first. So when I add this in by default, if I grab this, what this is visualizing is which objects you want within this this area or this radius to actually pick up reflections from outside. So I'm just going to bring this up a little bit. I'll bring up the radius. There we go. So I want to make sure that my mirror and these two are included as well. And if I now bake the indirect lighting, now you're going to see, oh, the red one shows up, and even bonus, I hadn't really talked about that one yet, but there's a green one up here that shows up as well. So there you can see that immediately makes a huge difference. So I delete the lighting cache again. Let's bake the indirect lighting, and it's the same box. You could also bake the cube map only. So if you've already baked your lighting and then you're setting up your reflections and you don't want to rebake your lighting because you had a whole bunch of irradiance volumes and it took a few minutes to bake, what you could do is just bake your cube map separately. That works just fine too. Now, you can immediately see the difference. So now we're actually able to render these off-screen objects because we've got the cube map. Now, let's just have a very, very quick look at the cube map. And I don't want to spend, again, too much time on this. If I turn the radius down and rebake this real quick, what you can see is anything that isn't within the cube map is actually not going to receive those reflections or refractions. So if we delete this, we want to make sure that our objects are always within the cube map. And even if I turn up the fall off, for example, just to show you. So we're about halfway through Suzanne here. And bake the indirect lighting. You can see some of that stuff, it's already starting to disappear over here, and we're really only getting correct reflections to about halfway. So again, you just want to make sure, and especially depending on your camera view and things, that we go into the settings here, we bring up the radius, and you can turn down the fall off as well. The radius back down a little bit. You want a little bit of fall off just so it's a little bit nicer. There we go. And now if we rebake the lighting cache, or the cube maps rather, we're getting nice reflections, and both our red and green objects are showing up as well, which is really cool. So now we've already got, there we go. We've already got really great looking reflections, but there's one more thing I need to talk about to really get the maximum out of these. And we can see this mirror object here. And this is where I can talk about some of these other settings as well. You can see sort of how some of the reflections here are getting smeared. You can see how this one sort of getting pulled back, and there's some weirdness. And now this is what this thickness is all about. You might be inclined just to set this to 0, but in general, you want a little bit of this thickness, and depending on your scene and the angle of the reflections of the objects that you're looking at, your reflections, you might be able to tweak these a little bit. Now you can fade out the edges of the reflections as well, just to make them look a little bit more graceful. So here, if I set the edge fading to 0, you can see we've got some of that reflection probe in here kind of giving us some reflections, but if we turn on the edge fading, it will nicely blend them together with other stuff. Now I found that the default is pretty decent, and we still need to do one more thing to really optimize this mirror and make it look good. So again, maximum roughness, you can basically set the maximum roughness of the reflections in the render. So if you have a material with roughness setting 1, and let's just do this on Suzanne, the maximum roughness of your reflections will actually be limited to 0.5 unless you really crank this up to 1. The main reason for it is noise. The more roughness you have, the more noise you'll produce. But it's good to know, and you can see roughness 1, the difference really isn't that huge. It's more in the way the object feels rather than anything else. Leave this at 0.1 or maybe even 0.2. There we go. And it's just a general control, but now you know sort of what to do with these, and clamping is basically going to tell the renderer how bright the reflections are before it actually starts clamping them down and ignoring them. So you can again play with that value if necessary in your scene. Now I did bring up the sampling quite a bit for this scene, which I don't want to forget to mention, just so we can get a bit of a final look, and you can see it calculates out a little bit as well. So if we bring the sampling down, and sort of similar to the the lighting as well, which we didn't really talk about with the shadows and everything. To get nice shadows and to get nice reflections, obviously we're going to have to bring up the sampling for our final result. There we go. And again, I've built a scene that's just sort of worst case scenario. Anything a bit more complex, you can have better reflections and it's going to look a little bit nicer, but it's just to show you, there we go, it just looks a little bit better even in our, reflections on the refractive object here. We just get more definition from the red, the green, and the blue everywhere. Now, only thing that's left is to actually fix this mirror, and as you can see, there's a lot of weirdness going on here, and those reflections really don't look the way they're supposed to look. So for flat surfaces, there's actually a second type of probe, and it's called a reflection plane. Let's just set this up, rotate this 90 degrees, move it on the y-axis, move it up, and I just sort of want this to be about on the surface of the plane. Now, the cool thing about these reflection planes is you don't actually have to bake these. They sort of work out of the box, even though they're not giving us any correct reflections right now. So what we need to do, is go into the settings and turn up the distance. And you can see as I start turning up the distance, now it's going to start looking for objects at a further away distance, and these reflections are going to start looking correct. Now, the other thing we need to do is just hit the S key to scale it up so it matches sort of the edge of our plane here. And now you can see this is a perfectly reflective plane. So we went from, and if I hide this, and turn off the lighting cache, we went from this scene with a whole bunch of reflective and refractive objects, and even if we turn off refractions, this is what we started with, and just by doing this, baking the cube map and turning on the reflection plane, we get a way better scene, and our metals and glasses look a lot nicer. Metals and glass materials look a lot nicer. So this is a very short chapter on how to get the most out of reflections in Eevee, and again, this is very scene dependent. There's scenes where I might turn all of this stuff on and take the extra time. There's other scenes where just the default screen space reflections give me enough to work with, and we can keep going. But you'll see all of that in the projects as well, whether it's useful or not useful. But again, if you have a scene with a lot of objects, a complex scene with a lot going on, you might want to set up multiple reflection probes, as you might want to set up multiple irradiance volumes for the lighting and get the most out of that scene. So yeah. That's just a very short overview of reflections, and let's move on to the next part of the course. One of the most fun things to use in Eevee are volumetrics. Real-time volumetrics are awesome. If we're using cycles or any other offline render engine, they take quite some time to render, and being able to do this stuff real-time is always a lot of fun. So let me just talk about how to actually optimize some of this stuff with a very simple scene. And again, we're going to just use Suzanne for this, and we're going to set it up in a very simple way. So I'm just going to grab one light, grab an area light, and I'm going to have this coming over from the side, out there maybe, and crank this up a little bit and look at our rendered view. So by default, we don't have any volumetrics because we need to add them in. And there's two ways to do it. We can either add in a mesh. So if I add in this cube, we can do, and actually let's add in our material here so we can see what we're doing. And grab a new material, and rather than using a principled BSDF, I'm going to use a principled volume and just plug that in, and now we get a volume as well. Now, one thing to note is if I just add some subdivisions into this cube, what you can see is the shape of the cube is actually round, but the volumetrics actually still stay in a box, and that's because if you're going to add volumetrics to an object, it's always going to use the bounding box of the object, no matter what the shape. So in our case, it's just using the bounding box of the cube. And it's something to consider that we can actually use meshes to shape volumetrics in our case. You can with cycles, but you can't with the Eevee. So that's the first way to do it, but I actually want to add these into our world shader. So I just want to add volumetrics to our world. That first one is just to show you that you can even control where they are and where you can put them. Sometimes you only need them in the front of the scene, but in our case, we're just going to use the world shader. It's a little bit easier that way. I'm going to plug in principal volume, and there we go. By default, we can't really see anything unless we get sort of close, and the reason for this is that the density is up fairly high, and a density of 1 in the world just means there's a lot of really thick fog everywhere. So we want to turn this down a little bit, maybe turn this down to 0.5, and I'm going to compensate just by really cranking up the lighting here, just so we have a really clear, I guess a really clear image of what we're trying to do. Now, As we zoom out, you might see, first of all, that the volumetrics start disappearing. And that's the first thing we can talk about here as well. And we'll probably loop back to it once we put a camera in. Actually, let's do that so we can talk about it immediately. So I'm going to move this camera back 10 units. And there's a reason for this. And I'm going to move this lamp, this light in here, just so we could talk about what's going on. And I could talk about optimizing the settings a little bit more. So you can see as I zoom out, we get sort of the volumetrics coming in and out. And the reason for that is not only the fact that the thickness increases because there's more fog between us and the light, but also because we've got a maximum start and end units here. So I know that this camera is about 10 units away from Suzanne. So if I set this to maybe 20, we've got the same amount of volumetrics being calculated between our camera and sort of the back of Suzanne. So now we're using about this much space to calculate our volumetrics, and you can see as I zoom out, they're going to disappear a lot faster. Now, if I set this up really high, for example, then they might show up a lot earlier, but as you can see, we're getting a lot of artifacts because this is down to the next thing, which are the samples. The best way to explain how these volumetrics are being calculated is it's taking like a number of slices in this volume, depending on where you're looking. So if we're looking here, you can see there's a lot of weirdness going on because it's having to sample first from 0.1 to 10 to where Suzanne is, and then another 990 units to the back. So there's a lot of information that we're calculating, but we don't really use. And these 64 samples, it's sort of taking 64 steps in that total space, which means we're getting a lot of weirdness. If we bring this back down to 20, now we'll get a really smooth result because those 64 steps are actually being distributed at a more correct distance, at a more even distance. And it's just going to look better overall. Now, this tile size actually becomes a little bit more clear once we start piping a texture into our density. And that's another fun thing we can do is we can actually control the thickness of the fog with the texture. So again, I'm going to use a wave texture. And for this, I'm just going to use generated coordinates because it's just going to use the default world coordinates because we're using a world shader. And I'm going to add 2 nodes in here. First color ramp and then a math node. And the reason for this is if I just plug this into the density, I'm going to delete the math node. By default, this is going from 0 to 1. And remember, we had our density set up to 0.05. So I'm going to set the same thing up here in the math node and enable it and set it to multiply. And now at least I know that, there we go, multiply. Now at least I know that whatever values are coming out of here, they're going to be between 0 and 1 because of the color ramp. But I can actually control the overall density of it just with this multiply. So there's a little trick for you there. And we bring up the scale because we want to see the sort of individual lines. So now you can see the wave texture, which if we just plug this into our background, you can see sort of the way it looks. It's just these lines. And if I bring up the scale, now you can see this is sort of what the wave texture looks in as an HDRI. That's where we're getting the lighting from it. If I just remove this, there we go, and plug the background back in, we can see that same texture sort of happening in our fog, which is kind of cool. And if we distort this, now we get fog that's a little bit more distorted. And let's say we put this on the Z-axis, and now we can get fog that maybe, something's going on in there, and we can mess with it more if we want to turn up the scale and turn down the scale. Now I'm going to add a lot of detail into this, so we can talk a little bit more about the samples and the distribution and that kind of thing. Before I do though, I'm just going to unplug this real quick and talk about the volumetric shadows because it's a little bit more visible without the texture in it. So volumetric shadows, as we turn them on, you'll see will actually give us better shadowing and take into account the shape of the mesh and try to project shadows in there as well. Now in general, if you turn these on, things are really going to start slowing down. So they're turned off by default for a reason. Yes, they give you more definition, but in some cases, like if you're trying to simulate heavy fog or whatever, it's not always necessary. It's just good to know that it's there if you need it, that you can turn it on. Now, for now, let's leave it on, and it's fine because we've got a fairly simple scene. It's not really gonna mess with it too much, but it's good to know that it's in there. Now, one of the other things that's still kind of bothering me before we move on to the texture is this light source over here. We know this is an area light, and I kind of want the light to be visible, but this bright dot is kind of annoying. So one of the things we could do is actually work with light clamping. and sort of find a sweet spot where we still get the lighting, but we don't actually get that bright spot. So if they set this to something like 10, for example, we'll still get the lighting, but we won't actually get that bright spot. And yeah, it's just a way to optimize it. Again, if we turn this down really low, it's going to start clamping down the lighting completely, and we'll still get the lighting, but we won't really get a lot of volumetric lighting. So it's just a way to control this, and maybe we could bring it up a little bit higher. There's no right or wrong here. It's really just your artistic vision that helps with this. But for now, I'm going to leave it to 0. It's just good to know we can fix this if it's a little bit ugly in our render. Because unfortunately in Volumetrics right now, lights are still being sampled as a single point, no matter what their size. You can see the actual lighting and the shadows change, but you can see that the light itself, unfortunately, still remains a point when it comes to shadows. So, or not shadows, but when it comes to volumetrics. Rather, like I said, shadows and light change very nicely, but the volumetrics don't. So that's just something to keep in mind. I'm sure stuff like this in the future will be improved, but for now, it's just something we need to be aware of. So let's plug in our density again and talk a little bit about our remaining options. So we've already optimized the start and end, and you can really see this with a texture in it. If I set this end to 1000 once again, just to overdo it, you can see those samples or those slices in the volume. You can really see them show up because it might only have 2 or 3 slices up until the monkey, and then it's going to try and distribute everything over everything else, which is not really what we want. So when you are using volumetric lighting, take into account what the camera can see and the amount of fog that needs to be calculated, especially distance wise. So setting this back down to 20, there we go. Now, the tile size is quite important as well. If we set this down to 16, you'll see we get these sort of splotchy looking, interpolation artifacts, I guess, as it's trying to interpolate the texture at a larger size. Now, there's a really big difference. You might be tempted just to set this to 2 pixels and be like, all right, done. Let's just always leave it at that and save it to my default file. Problem is, when you get to 4, it's still fairly performant. When you get to 2, things start to slow down a little bit. And I don't know how visible it is in the recording, but you can definitely feel that it's getting a bit sluggish here, just moving in the viewport. And if we just hit render, and this is just a full HD image with only a monkey, remember, 1 light and some volumetrics, setting the tile size to 2 gives us 6 seconds for a single frame. Now that's a lot. Granted, we are getting all of this detail that we're getting from our beautiful texture down here, but even just setting this to 4 and rendering again, you're going to see now we're down to 2 seconds. So that's 1/3 of the render time. So you got to ask yourself, is it really worth it? Especially when you have animation moving through, unless you're doing something very specific. It's very good to know that you can definitely get away with larger tile sizes. Now, samples we've talked about, if we set this to 1, for example, you'll just see like 1 or 2 slices between us and the end of the volumetrics calculation, which means you're going to get these weird lines. If we set this up to 256, we're going to get really smooth stuff, but again, as we start rendering, if we render this out, it's going to take a lot longer. Let's give it a second here. You can see this is again set to a tile size of 4 pixels, and we're getting those 6 seconds again. So there's a lot of optimization to be done, and to get the most out of volumetrics, you really need to understand how this stuff works. Otherwise, you're going to get really long renders that are probably not even necessary because you were like, I'm just going to crank up the samples and it'll look fine. So yeah, that's most of it said. The only thing we didn't really talk about is the distribution. Basically, what this controls is how the samples are distributed, if there's more samples either closer to the camera or further away from the camera. And you could tweak this a little bit depending on your scene. I found that the default distribution works quite well, but again, sometimes you might want more samples closer to the camera because you've got a lot of fog going on, obscuring an object that's really close. Or if it's obscuring objects that are a bit further away from the camera, you might set the distribution to set it up to where there's more calculations going on around that object in the distance. So you get better shadowing and that kind of thing, and better lighting around it from the volumetrics. Now, one last thing to talk about as well is that volumetrics don't only support just fog. We grab this and we grab another color ramp, and what we're going to do is we're really just going to grab the very edges of these of this thickness. And we can, if we add a shader here, and we grab an emission shader, so the emission shader can also be used in the volume slot in Eevee as well. you'll see is if we really bring this down, yeah, it's quite hard to see. Bring down the emission. No, unfortunately, it won't be able to show it. So see if we can't really get this to work. But basically, what I'm trying to show is that there is a way to get sort of emissive. Here we go. We can get the edges of this to be emissive, and maybe if we turn down the size of this. So there's some nebula effects and things to be had as well, because now we're just grabbing the very edges of our texture, and we're piping those into an emission shader as a volume. And you can see this works pretty well, and you can get almost nebula-like effects from this as well. And you could even go in, throw in a color ramp. And this requires a lot of tweaking, which means we're not going to get a very great result just from the start, but it's good to know that this is possible as well. So again, they're not going to emit light, but they will give us a nice sort of almost nebula-like state, which we could use, and we could tweak this. Again, you could see we could tweak this and this, but it takes a lot of tweaking to get it to look good. But now we've got nebulas, and we could just plug this in by itself. We don't need necessarily to use it with the I was going to call them the fog itself. But again, it always just looks a little bit better when you add them together. And I'm not even getting any results. Maybe I need to turn the strength up. No, there we go. Let's just leave it at 0.1 and mix it back in the fog. Like I said, I wanted to show this, but you can already see how finicky it can be to get it right. But it's nice. It's just an effect that's in there. Might be usable, and I've swapped around my color swatches. There we go. You can mess with the scale. But yeah. There's a lot of fun to be had here, and because it's all real time, you can get instant feedback. But remember, this is all an emission shader, so if we set the end up higher, because it's emissive, we'll actually always see the volumetrics no matter what. So doesn't matter where we are, it's going to calculate them from 0 to 20, and as we move through them, you can see there's a lot of craziness going on. But yeah, just for stills, I've made animations with them as well, but it's cool that it works. And if we just want to go back to the regular volumetrics, now we want to bring down the scale, maybe bring contrast down a little bit so we've got more smoky look. We could even mess with the scale to make it look a little bit cooler. There's a lot to be done here, and there's a lot to unpack, but mostly I just want to talk about how to optimize this. And again, the tile size and the samples are going to be the main two things that slow you down when you're trying to set this up. So yeah, for maximum effect, make sure you set your start and end correctly, and make sure you don't overdo it on the tile size and the samples. Sort of trying to find the minimum you can get away with most of the time. So yeah, with that said, it's time to move on to the next section. So as a very quick sort of addendum to the volumetrics chapter, I want to talk about a cool little trick you can do in Eevee as well, which is quite a bit of fun. And to do so, I'm just going to set up a cube. And I'm going to grab the back here and just move it out maybe 20 units, something like that. Scale it up, not in the y-axis, but the other two axes. Really, what I want to do is just set up a particle system and throw some lights in there, because that's something kind of fun you can do with Eevee, is you can make a particle system and throw a bunch of lights in there and then add volumetrics to them. And again, this is just a very quick trick rather than something very specific. So I'm going to grab a point light and I'm going to duplicate it twice. And I'm just going to illustrate this with red, green, and blue again. Just to keep it simple. Green and there we go. I'm going to throw them in a collection called lights. And I'm going to call this emit.lights. So let's actually set up these lights, and let's set the blue to be blue. Set this to at 50 to start with. You can always bring this up later. Set this green, 50, and set it to red, and 50. There we go. I'm not going to change much, but I am going to add a world shader with a principled volume in here, and a camera as well. Let's do that first. There we go. And now we're actually looking inside the cube. Let's go into our world shader, add a volume. There we go. And now when we set this to rendered, you can see these three lights, but I want to turn them off for now. And what I want to do is add in a particle system. I'm going to set the number to maybe 50. Frames start and end to -1, so they're all in there, and the lifetime to 9,999, just so they're in there for the duration of whatever we're doing. And we're going to grab the volume. So now we can see these particles. What we can do in render, we can set this as collection, our lights collection. Now we can just bring down the density a little bit. Let's see, there we go. And let me grab my camera as well, because it's still in the lights section apparently. I'm going to set my Asper 2 to black. There we go. And now we've got a cool sort of lit scene, and we didn't really have to do much for it. Now I am going to turn off my emitter as well. So let's not show the emitter during render and not show it during in the viewport display. So there you go. Now again, I might want to tweak these a little bit. I think I might have set them up a bit high. Quite a number of them. There we go. Really, all I wanted to do with this is just illustrate that you can do some really fun stuff with these lights. These maybe are Christmas lights or something that you could use, and we could move our camera through them. So grab the camera here. Let's animate it from 0 all the way to maybe 25. And make sure we do one more thing to our particle system, and that's set the physics to none, so they'll stay in place. And now let's grab the end of this, set it to 50 units. So now we've got 25. We know our camera is moving 25 units, and our thing is 50 units long. So what we might want to do now is sort of what we looked at before. We might want to optimize our volumetrics here, maybe set the end to 25 because we can only see sort of so far. But as you can see, we get a very spacey, cool looking thing. And I just wanted to throw this in there as a little bit of an extra. And again, when we talk about the clamping, we could turn on the clamping, and now we just get these shades of colors, and you can really just go in and customize this as much as you want. Again, if we grab the emitter, what we can do is in the, where are we? Render settings. We could say use count. So for example, what we could do is we could have 3 times as many blue lights as the red and the green. And now you can see it's mostly blue, or we could have mostly red lights just by setting up the same way. There you go. And this is all very quick and easy to set up. And if I'm doing things like tunnels or other things like VJ tunnels, whatever, this is so useful just to be able to set up and fly through and not have to do a lot of work. So now, for example, because there's more red lights, we could turn up the green and the blue just to contrast that a little bit. Now we get a lot of really cool, interesting things. And again, we didn't have to do very much for it. If we want to go really crazy, we could add a texture in to our principled volume as we did before. So let's just set this up very quick. Go, density is 0.1, so let's add our math node here, set it to multiply and 0.1. That way we're controlling the density of the wave texture. And what we can do as well is add that same color ramp in as we did before. Maybe set it to diagonal this time. Bring up the scale so that's a little bit larger. There we go. Bring up the distortion. Just bring up the contrast a little bit. And this is what I was talking about in the previous video, that you can get like nebula-like effects. You could add in the emission in here as well. You can see even just this is quite useful as a render. And if we just hit render, we could add more density in, or more lighting into this as we needed it. But just as something like a nebula or some color, whatever, I don't know. I don't really know what to call this, but it's a fun little trick. So it just goes you to show, with a little bit of outside the box thinking, we've added these lights in, and let me turn these off so they're not visible in the scene, but only in the particle system. You can add a whole bunch in. Now, one thing I do want to mention, let's bring up the detail and we get a bit more detail. If we go into our particle emitter, if we turn this up really high, let's say 250, you will see some slowdowns. You can see it's already chugging a little bit. You don't really want to overdo this. If I set this to 750, you can see it's having a really hard time. That being said, it still renders. If we hit render, we need to give it a second here. Come on, you can do it. There we go. It's 8 seconds because we have so many lights, but at the same time, it's a cool effect. So it does work if you need something like a nebula or background. I just wanted to show you this in addition to what we talked about in the volumetrics section. So yeah, with that done, let's move on. I'm going to turn this down a little bit. So when you open it, it's not as crazy, but there you go. Hopefully you can have fun with this and create your own crazy setups. And yeah, definitely show me if you do. So, all right, let's go to the next video. So there's one or two more things I want to talk about when it comes to Eevee that are sort of, I guess, gotchas, you could call them, but just one or two more controls that might be useful if you're trying to do something. So in this case, I've just set up a very simple scene to demonstrate sort of some of this stuff. And we've got two icospheres here, and they're really just meant to give off a lot of bloom and a little bit of reflection. And as we saw with the reflections before, as we go in, sort of disappear a little bit. We could fix that with reflection probes, but that's not really what I want to talk about in this video. And we've just got some Suzannes in the distance. And yeah, I just want to talk about one or two things really that are left that might be interesting to think about. So right now, if I look at this in the viewport and I hit render, you'll see all of a sudden all this bloom on the side is gone, all these reflections are gone, even though these are like almost in the scene. And we could emulate this effect to see as these disappear from the view, and this happens in the viewport as well. Now we basically get our rendered view, and this is kind of annoying because you want these to sort of disappear gracefully. And if you were to render an animation, the second these disappeared out of sort of the side of your frame here, all that stuff would disappear. So there's one way to actually fix this, and it's in the film section down here. It's called overscan. Basically, what this is going to do is when Eevee's rendering, it's not just going to render your regular resolution that you've set up here, but it's going to render a number of % extra, which means if we just turn this on compared to what we had before, now we'll still get some of that bloom as they're outside of the frame. So this just gives you a little bit extra to kind of have some effects that might still be needed. You see some of these screen space reflections are coming back as well. Now, if you baked a reflection probe, that wouldn't have been an issue, but just in case you want to use this, this is one of the things I generally turn on by default. I think it's at the 3% by default. You can go up to 10 on the slider if you really want to. Now, obviously, it's going to slow down your render because it needs to render a little bit more, but it does help with stuff that's disappearing. Again, if we turn this off, even though they're really close to the frame, like, oh, actually, let's undo that and move this in even further. Like we could really straddle the edge of the frame here, and yet it could completely disappear if we turn that overscan off. The moment we turn it on, it's going to respect the fact that there's some stuff still here, and especially with bloom and other things, it's going to nicely sort of more gracefully fade out towards the edge of the frame. So that's definitely one of the things to keep in mind. Now, the second one to keep in mind, and I'm just going to go over this very briefly, is motion blur. Basically, we can turn motion blur on, and let's animate our camera. Actually, let's animate Suzanne first. So let's set quite a short animation time, maybe 30 frames. Go grab timeline here so we can see what we're doing. Animate her down here. Insert a single keyframe. And then at 30 frames, let's animate her up. There we go. And let's say she's here in the middle. She's kind of moving, and I'm going to overdo the motion blur. And as I render this, you'll see absolutely no motion blur. And that's normal because, again, we're dealing with some of the limitations. While this might work perfectly in cycles, object motion blur, so any objects that are moving or deforming, doesn't work, unfortunately. Now, I'm sure this is something they're working on and will be added in the future, but it's something to keep in mind nonetheless. I'm going to delete these keyframes for a second. And now I'm actually going to do the same thing with the camera. I'm just going to animate it over a few frames so we get a really over-the-top result. So move this camera down real quick, animate this, insert keyframes, and maybe over 10 frames or so. Let's move it up about there. Insert a single keyframe, and let's clear these ones that we're not using. Oh, clear single keyframes. Thank you very much. And now with motion blur turned on, you can actually see the motion blur show up. So it does work for any type of camera movement, but it doesn't work for any type of object movement. And I just wanted to make that distinction very clear. So you know when you turn it on and you don't see any motion blur, it's probably because your objects are animating and not your camera. So if you're flying through stuff, this will work quite nicely. But if you've got a static camera with objects moving through it, at the time of recording in version 2.83, that doesn't work yet. So hopefully it'll do it in the future, but it's good to know that motion blur only pertains to the camera. Now again, I'm going to clear these keyframes, set this back to 0, and talk about the very sort of last gotcha in this case. And I've got an empty setup here so I can turn on depth of field in my camera. And let's do exactly that. Turn it on, and let's grab this focus object. And what I'm going to do now is I'm just going to really overdo the depth of field. Not to be realistic or anything, but I just want to overdo it to a point where everything just completely slows down. You can see my UI completely and utterly slows down the moment this depth of field comes into play. And really all I just wanted to do is talk about one last setting in here, which is called depth of field. And basically what you can do is, let's say you want to create a very shallow depth of field look, but really, you know, you just kind of want this part to be somewhat in focus and want the other parts to be out of focus. But let's say you've got a really large scene and a lot of depth in the scene. What you can do is actually control the maximum amount of fuzziness. So, well, fuzziness, the maximum amount of blur basically for your depth of field scene wide. So even though these are really far away, as I mess with this f-stop, even if we get down to the very, very low settings, it's going to just clamp that down. And like again, if I set this to 100, you'll see everything slows down and gets really crazy. You can see if we try to render this, this is probably going to take forever. Let's hope it doesn't crash because we're kind of really pushing it way further than it should. But yeah, as you can see, this is taking a while. And I actually went to go grab a drink real quick because this ended up taking a minute. So that just goes to show you, okay, this is a very extreme example. You'd probably never use it that way. But if we just set this down to 10 pixels now and let it re-render, this only took less than 2 seconds. So again, it's good to know that there's an overall control here to just, I guess, control the crazy amount of depth of field if you have a very, very shallow setting. Now, generally, this is completely over the top. I mean, you'd almost never set it this small. Maybe something like this is a bit more normal. And then you can leave it at the default as long as it's not causing any issues, but it's good to know that it's in there. And that's sort of the last little thing I wanted to talk about when it comes to Eevee. The only other thing that I tend to set up a little bit higher is the cube size of the shadows, just so we get a little bit more definition in the shadows. But most of it, I'm not going to go through every single setting because there's really no point. Most of these are the ones that you'll use artistically, and the other stuff is more down to performance and technical things. And you could read up on the documentation, but most of it kind of, yeah, makes sense in the first place. So hopefully with these last couple of videos, you've had a nice overview of what you can do with Eevee. And in the next one, let's talk about how you can push it even a little bit further and how to get some of these renders out and even do a little bit more with them after the fact. So yeah, let's move on to that. So for this video, I've set up a very basic scene so we can talk a little bit about post-processing and compositing and that kind of thing. So let's just talk a little bit about the process of it in Blender. And as you can see, I've got 3 lights set up. I've got sort of a metallic Suzanne, and then her eyes are an emission shader. Now, I'm not going to bake any indirect lighting and all that stuff for now. I just want a very simple example I can talk about. And if I just hit F12, I'm going to render this, and I get sort of a rendered view. There's a little bit of noise in here and that kind of thing. But let's say I've rendered this out, and again, this is more just to illustrate what else we can do once we've rendered something. Now, one thing I have done is actually turned off bloom in the render settings, and there's a good reason for that because I want to talk a little bit about using the compositor sort of to do kind of a post-production pass on our render. So that's the cool thing with Blender, is because it's got a compositor built in. We can use this with Eevee as well. So we go into the compositor view, turn on use nodes, and now whenever we render something out, and it looks like I've already got some passes set up here, I only want to talk about those later, so don't worry about these for now. I'm going to turn these back off. We'll talk about those in the next chapter. But let's say you just get your image out and that's it, and you want to clean this up a little bit or maybe add a few effects in. And the cool thing is the compositor sort of does its work after you render, and you could save out your final image. So I use this quite often where I'll render something in Eevee and just do a little bit of touch-up in compositing. And one of the things we could start with, for example, is a glare. Now, obviously, I'm not going to go over every single one of these things, but I just want to show you some of the things that we can do. So if we grab this glare node over here and we plug this in, and we just plug this into the end of our compositor, you can see with the bloom turned off, we now are able to add in our own bloom, and we've got a little bit more control. So if we set this to fog glow, this looks a little bit more like bloom, and this actually looks quite nice. Now in general, what I'll do is I'll set the mix to 1, and that just gives us the glow by itself. And then we could mix this in separately. So if we set this to add, now we're grabbing our base image and we're mixing in the glare separately. And now we've got a control over how, like a very easy control over how much glare we want on top of that. Now, before we mix that in, I actually want to fix one of the things in my render, and it's the fact that we still have a fair amount of noise. Now, in general, the denoiser is meant to be used for cycles because it has extra passes, but I've found that it actually works quite well without those extra passes on Eevee renders as well. So just by plugging this in, you'll see this will take a second, but it will take out some of that noise. It's not perfect, but if we turn it back off, you can see it really does a pretty good job in trying to interpolate in between them. So this is our normal render size, and you could get away with very little Eevee passes just by denoising this after the fact, which is quite nice because yeah, it just gives you more flexibility. And again, you could turn this on or off if you wanted to. Now, let's get back to maybe one last sort of effect that we can add into this. So we've got our image, we've denoised it. And let's say we want to add just like a vignette or something to darken the edges to maybe bring in Suzanne into focus a little bit as well. So we could add something like an ellipse mask. And really, if I just plug this into the output, you'll see this is just going to generate a white ellipse. So let's set up the height to 2. So it's going to be 200% in height. Let's just set up the width here to be about, just the edges there. And what we're doing will become clear in just a second. Actually, let's plug this in so we can kind of see what the result is. So again, I'm going to use a mix node for the color and set this to multiply. Where is multiply? There it is. And now what's going to happen is if we plug this back into our output, for a second, everything that's white will just let our image come through, and anything that's dark will actually be darkened down. So what we could do is add a blur node in here. And I generally set this to fast Gaussian because it's a little bit quicker, as the name would suggest. And I'm just going to turn off the denoiser while I'm doing this, so the compositing goes a little bit quicker. And rather than using like a pixel size, I'm just going to set this to relative. We could just choose a percentage of the width, and let's say we set this to something like 35%. Now you can see we get a nice little vignette effect that we can turn on or off, and we could even take it away a little bit if we want to. But like I said, I use this quite a bit in conjunction with Eevee renders just to have them pop a little bit more. It gives you just a little bit more of a cinematic feel if you can add in some of these effects after the fact. And again, with denoising, we could even go crazy and add in some, where are we? Maybe some lens distortion. And what this is going to do is it's going to give us sort of fake chromatic aberration if we set up the dispersion. I'm just going to overdo all of this stuff, and it won't be super visible, unfortunately, because we don't have a lot going on, but you can kind of see. Let's say I just kind of go over the top with it. There you go, you'll get these sort of fringing effects. And obviously we're not creating this to be anything beautiful, but I just wanted to show you, we bring in the distort a little bit, we can sort of undistort it and fit it to the camera. All I'm meaning to do is just to give you the idea that you're not stuck with this render. You could do all kinds of things with it. You could even add a little bit of color correction in here if you wanted to. So grab curves, set this to film-like so it responds a little bit nicer. Maybe let's mess with the red. And again, the denoise can be a little bit slow, so I'm just going to turn it off for now. Yeah, we're getting some issues here. We might have to switch back over to standard. There we go. This isn't a super high dynamic range image, so you might get some issues with the film-like setting. And we could just mix some of this stuff in and out, maybe take out some red, bring in some green. And again, not looking to create a piece of beautiful artwork, just trying to maybe add in some subtle details. If we bring in the blue, here we go, something like this. And just to show you at the very end, all I'm going to do, what I'm going to add in here is called a switch node, and that lets you switch between two different inputs. So in the first input, I'm just going to put in our raw image. So this is what it looked like. Now when I switch this on, we can see the composited result. This is what it looks like with a little bit of compositing. So just those few little things we could add. And of course, you don't have to do this in Blender. You could do this in After Effects or any other application. And we'll talk about how to get more information out of Blender in just a second to other applications. But it's good to know that even in Blender, you can add in a little compositing, and that's fine. Now if we render, what will happen is if we hit F12, we'll get our Eevee render, and then we'll do our compositing. And now if we've set it to render a sequence, this is the final result that will be saved. So again, you can see this just looks, in my opinion, looks a little bit better than what we got before. And yeah, Compositor, it's not the fastest or best compositor on the planet, but adding just stuff like this into your Eevee renders can really make them shine and really make them look a little bit more beautiful. So yeah, with that said, in the next video, we'll talk about how to get some of this information out, like passes and things like that. And if you're more of an After Effects or Nuke or whatever user, you can still do a lot of compositing in there as well if you prefer that. Okay, so let's move on to that. After seeing what we can do in the compositor, I want to talk about getting stuff out to, let's say, an external application and sort of what your options are to do so. If you're coming from like a full-on renderer, you probably already know about render passes, and that's kind of what we're going to talk about, but also about how we can get them out of Blender, maybe in a bit more optimized way, for example. So first of all, let's have a quick look at the scene. I've just set up a very similar scene to what we had before, but we've got a little bit more going on, and it just shows you what is and isn't available in the passes right now and how deep they go. Again, if you want full crazy depth when it comes to passes, you're probably better off using cycles, but there are quite a bit of options in Eevee right now. So we've got a glass torus here, we've got a metallic Suzanne, just a green plastic icosphere, and a cube with some subsurface scattering, as well as some emission in Suzanne's eyes. Now, compared to the previous example, I've turned on bloom again, just to be able to talk about some of these passes. And the easiest way to do so is just to turn all of them on. And there we go. Grab all this and just turn all of them on. Now I'm just going to hit F12 for render, and it's going to render all those passes. Now in our rendered view, let me just zoom in a little bit. We can actually see all these different passes. So let's run through them really quickly. Now depth is basically the actual depth of items in your scene. So if we look down here, down the bottom right, as I'm right clicking, you can kind of see the values go up and down. So there's only one value, which is called the Z value, which is down here. And basically, this is just the distance of the mesh to the camera. So if we go back, for example, we know over here in this part of the scene, this one's going to be a little bit further away, and maybe Suzanne here in the middle is a little bit closer. So if we go back to that depth, if we look at our cube and we look at the Z value, this is 8.9. If we look at Suzanne here, this is going to be 7.8. So it's really just grabbing the units of your scene and putting them in a depth map. Now this looks white because from 0 to 1 is sort of from black to white on your screen. And this is a very crude explanation, but everything above white will actually just turn white and look like it might, shine brighter or whatever. But in our case, it's just good to know that this is just the raw depth value if you want to do any kind of depth of field after the fact. And then normals are just going to give us our normals of our meshes, which is fine. And now we get down to the meat and potatoes. So now this is going to give us our emission. And as you can see, if we look at these values, so I know I'm emitting about, 5 or I think 10 units, I think 5 units for this. And you can see the raw values at the very bottom down here is going to be 5 in the R channel. So this is going to emit light. Now we've got AO, which is just an ambient occlusion pass. We've got environment. There's nothing in here because we can't actually see our environment. So anything that would be in the world shader would show up in here. We've got a shadow pass, which is a little bit rough, just due to the nature of shadows in Eevee. And also we could really crank up the settings and try and get a better shadow pass out of here. But again, it's just a little bit rough. We've got a mist pass, which if we go back out here, we can actually set up a mist pass in our render settings, in the world settings, and we can just set it up wherever we want. So if you want to render like a landscape and you want to composite in some haze or something, you could always use a mist pass for that, and you could just set up the start and end. Then we get into some more sort of compositing direct territory rather. So we've got the diffuse direct and the diffuse color. And again, if we go to our passes, we can see all of these in here. And maybe let's just leave this open for now. So here you can see diffuse light and color. So that's going to be diffuse direct and diffuse color. And then glossy direct and glossy color. Two separate ones. Now there's no glossiness in here because it emits, so that's why that turns black. And then we've got the bloom separately, and we've got volume scatter as well, but I didn't put any volume objects in here because, you know, it's just I want to keep it fairly quick. But again, you could get the volume stuff out separately as well and composite it back over. Now let's turn off what we don't need. So I don't want any depth or mist. Normals might be interesting. Yeah, let's see what else. We don't need the volume. We don't need the environment, we don't need the shadow. I just want a couple of them to show you how we can set some of this stuff up. So by default, if we go in here, what I've done is if I go to my render settings, I've set up already this be an OpenEXR multi-layer. So that means I've set it up to be RGBA and half float. And that means we're going to get our values, even the values that go over white in the viewport or over red in this case, we're going to get all those values out because we're using an OpenEXR. If you don't know what an OpenEXR is, basically if you're going to do any sort of compositing, it's going to be the format to use because it retains a lot more information than say a JPEG or a PNG. And I would suggest looking up on that kind of stuff before you get into compositing in the first place. This really is meant for people that already know kind of what's going on with this stuff. So with that said, I'm just going to render the one frame. And let's go to our temporary file manager here. And let's see, I'm going to throw these two out because I was testing stuff earlier before, but basically this is the EXR that we get. If I double click it, I'm going to open it in an external application. And we can see, if we turn on our layers, we can actually see all these layers show up. So we turned on ambient occlusion, we turned on bloom, we turned on combined, diffuse color, diffuse direct, emission, glossy color, glossy direct, and normal. Now, let's say, just for the sake of it, we don't want to have to deal with these two separate passes. We just want a glossy pass, and same for the direct. We just want a direct pass. We don't want to have them in separate passes. We want to composite them already together in Blender and then output those as a pass to go to our other compositor. And we can do that very simply by switching over to the compositor view. I'm going to turn on use nodes. Now by default stuff is going to show up in here, but because I'm already messing with the scene, I'm going to have to set it up myself. And I want to set up a composite for the output. And really what this is going to do, this is just your main output that you want to output. And instead of using this, actually, I'm going to throw this out. I'm going to use a file output instead. Now what this does is it gives you the option to output a separate file next to this output file. So if we set this back to JPEG, I'm going to go back to our file manager and delete the one that we rendered. So let's call this our custom EXR. There we go. And we're going to leave this set to multi-layer as well because we want everything that we plug into this node, and we can add a whole bunch of inputs, and we'll do that in just a second, to be in one EXR file the same way we did it over on the output here. Now, I'm going to plug in my, let's see, we want our normal. This takes a little bit of setting up. We want our AO. Then we want our diffuse. We want our glossy pass. Call this emission. I think we have all of them except for the bloom. And call this bloom. Now, if we just plug these in, you'll see as I plug in the normal pass, the color of the slot will change, so it knows it's a data layer and we'll save it accordingly. AO, diffuse, and diffuse direct. So we can't plug these in together, and that's exactly what I wanted to talk about. So I'm going to turn on the backdrop here and just really quickly talk about compositing these together. So let's grab a color node, and grab a mix node, and let's put these two together. So we've got the diffuse and the diffuse direct. And if we multiply these, we're actually going to get the correct diffuse pass. And now what we could do is output that result to the diffuse slot for our custom file. We could do the same thing for our glossy passes. We grab these. There we go. If we turn off the multiply, this is the first glossy pass. And now we get what we need, and we can plug this into the glossy. And then all that's left is our emission and our bloom. There we go. I'm going to turn off this viewer again and turn off the background and just do a little bit of housekeeping. There we go. We can move this up a little bit, and we're going to do the same thing here. There we go. And this really is just to move stuff around and make it a little bit more clear, so that when you open the file, oh, again, wrong button. When you open the file, you can kind of see what's going on. And it's not this big noodly mess. There we go. So all that's left to do is just to render this out. And one thing to note is if you're using this, this custom setup, even when you're going to render out a still, normally by default Blender doesn't save any stills that you render. But in the case of this output, it actually does. So if I just hit F12, and go back to my temporary directory that I'm rendering to, you can see we've got custom 001 because it appends the frame name. If we double click this now to open it up in our external application, we turn on our layers, you can see we actually have those layers that we set up with the composited diffuse and the composited glossy and the other ones that we added in as well. So this is a really nice way to control your EXRs. And if you want to go even further and you want these passes out separately, you could do that as well by setting this to EXR. And now you can see for each set of these nodes, and unfortunately it keeps the names for the multi-layer, but it uses different names for the EXR. You could even use a custom format for each single one if you wanted to. And I'm going to leave these set to OpenEXR and just hit F12 again. And what you'll see in the file manager here, now this custom EXR is still the one that we used, that we rendered before, but now we get a little folder called custom, and now we get all those separate passes in. So this one, let's have a quick look, is the normals. This one is our AO, and so on and so forth. Now you're going to have to obviously fix the naming a little bit by setting all this up again and making sure you append the frame number and that kind of thing. But it's good to know that you can either output these as one full-on EXR or EXRs with different settings, different compressions, that kind of thing, depending on what you want for the different passes. So yeah, that's just a very quick overview of passes with Eevee and outputting to custom EXRs. I wanted to throw this in anyway. I know it's a bit more technical than some of the stuff we've talked about so far, but yeah, you can really optimize your EXRs with this file output to only grab what you need and maybe save a little bit of disk space and that kind of thing. So yeah, with that said, it's time to move on to the next section. This is just a very quick video to talk about batch rendering with the built-in options in Blender. So I've got two files here, one with a red monkey going from left to right, and a second file, so let's close this. Same thing, this time it's just a green monkey going from left to right. And I've got these set up to render in two different folders in a directory here. And I just want to talk about, you know, command line rendering or batch rendering, because you can batch render with the command line. And the reason I want to talk about this is some of these Eevee renders are so fast. You could set up, you know, maybe 5 or 6 scenes in a day of a project. And rather than having to babysit every single scene all night when it's rendering, you might just want to render these all out together in one go and then just look at them in the morning. So that's exactly what we're going to do. We're just going to do this using the command line, and Blender has a few commands which might be easy to understand when you actually see them being used. Now you can do this on Linux, which is what I'm using in this case, but you could also use it on Mac or Windows. And the commands for Blender itself are exactly the same. They might vary a little bit differently when it comes to navigation and other things in the terminal, which you'll have to get used to for your particular platform. Now I'm gonna move over to my Blender folder first of all. So I'm gonna change my directory to my Blender folder. And this is where the Blender executable actually lives. So on my system, and I've actually go to my home folder here, we have Blender dev folder, and that's the Blender that I'm using. So I know that's in there. I just wanted to show you as well. Now, what we're going to do is if we do a /blender and we hit enter, it's just going to load up Blender, and that's it. And that's fine. But what we want to do is we want to do the same thing, but rather than telling Blender to open up, we want to tell it to kind of, basically start rendering something in the background. So the way we do that is we use the same command, only we type in -b, and that stands for background. And now we want to tell it like, okay, so I want you to open up in the background so you can start rendering stuff. And first of all, I just want you to start rendering this first file, I guess. So to do so, we'll throw that in and we'll put in -a. And that basically means render all the frames in this, save them all out, and that's it. Cool. Now, if we want to batch render this, all we really need to do is just add a space, throw in our second file, and add -a in here as well. So the way Blender interprets this is, all right, I want you to render in the background, I want you to render this file, and I want you to render all the frames in this file. Now for the second file, let's say each one of these animations is only 10 frames, so we can watch it happen real time. What I want you to do is actually render from frame 3 to frame 7. And we can set that up very easily as well. So before we tell it to render everything, we can actually specify which parts of the frame to render. So let's go to -s, and that's going to say, okay, I want you to start rendering from frame 3. And we're going to type -e, and I want you to render up until frame 7. And then between those two values, I want you to render everything. So now if we hit enter, you'll see it's actually going to start rendering these, and let's just give it a second. It's fairly quick. I just want to show you. So you can see the first file is being rendered and all 10 frames are being rendered. And now when the second file starts, you can actually see frame 3, 4, 5, 6, and 7 being rendered. And if we go to our batch folder here, now you can see all of these frames have been rendered. Just open this up. You can see the 10 frames here for Suzanne. And in the second folder, we can see the frames here for Suzanne as well. Now, I'm just going to open up a browser real quick. And let's go to the Blender documentation. Let's go to the general manual. And what you can see is we type in command line rendering, or just type in command line. It's going to give you a chapter on command line rendering. It'll show you all of the different commands it has. So there's a lot of stuff you can do. So what we just did is render in the background and render a certain file. -f will give you a certain frame. We used start and end, for example, which is a little further down, which is down here. But there's a lot of these arguments that you could use. Now, obviously you don't need to know all of them by heart, but I just wanted to show you this because I use this all the time. So I can have stuff rendering in the background and I can still use my computer for other things. And I can easily render multiple different blend files all at once. So yeah, a little bit outside of what we were doing before, but useful nonetheless. And yeah, that's it. So let's move on to the next one.